Hey guys, hi, welcome back. So, in the last video, we have discussed the triangle problems. Okay, we will have placed the charges at the three corners of a triangle, and we were asked to calculate the Coulomb force at any one of the charges or at the center of the charges. Okay, here we will place the charges at the four corners. Where? At the four corners of a square, and you are asked to calculate the charge either at the center of the square or at any one of the corner. Okay, these type of questions you will be getting. So here first we will see the theory sector. So if you are having four identical charges means four charges of equal magnitude. Means if you are having here plus q, this is also plus, okay, plus q. Here also plus q and here also plus q. And you are asked to calculate the resultant force. What you need to calculate? Resultant force at the cross sectional of the diagonal. That is the center, okay, cross sectional of the diagonal or the center of the square, both are same. Okay, so what the charge will be, sorry, what is the force, resultant force? So here if you say this is a positive charge, okay, and here at the center if you are placing any charge plus q, that in that case what force will be exerted on the center? If you see this is positive charge, this is positive charge, so this side the force is what? It will repel, right, this charge. And from this side also this force, this charge will apply a repulsion force, right? So this force will also repel this side. And for other two sides also, if you see, this charge also will do what? It will repel, and this charge will also repel, right? So in this case the force is what? Repulsion force. And if you see, this force will cancel this force will cancel this. Now here in this case, if I change this particular charge to be minus, then what will be there? This force will be same, this two force will be same, but this charge will also apply repulsion. But what will happen with this charge? This is a negative and this is positive. In this case what will happen? This charge will be attracted towards, okay, the negative charge. So here if you see, both the charges are having same direction of force, right? So this charge will add up and you will get the force. What I mean to say is that if you are having four charges of equal magnitude at the four vertices of a square, then if you are asked to calculate the net force or the resultant force at the center of the square or the cross sectional of the diagonal, then for symmetrical charges you can say, okay, for symmetrical charges the charge at the center is always zero for equal magnitude. And if you are changing the nature of the charges, then you will get some effective force which is not zero, there will be some value. Clear? Is that clear? So this is for the center. Now next, if you see, if you are asked to calculate the force, okay, at any one of the corner, suppose I'm drawing this to be a square, okay, it doesn't seem to be a square, but consider it to be a square. So this is a square A, B, C and D. Clear? So here if you see, if I am placing four charges of equal magnitude, okay, suppose this is plus q, this is plus q, this is also plus q charge and plus q charge. And the side of the square, we know all the four sides are equal. It is A. Diagonal, you can calculate it to be what? It is root 2A by applying the Pythagoras theorem. I think these things are clear for you. So you can just calculate it and see. Now, if I ask you to calculate the net force, okay, at the vertex B, okay, at the corner B, then what you will do? First of all, you will see the force. Okay, first you will check the forces. So if you see here, the charge which is placed at the vertex A, it will repel the force, that is force on B due to the charge A. It is in this direction. Similarly, force on the charge B due to the charge placed at C, it will be in this direction. And force on the charge B due to the charge placed at D, it will be in this direction, right? This is what you're having. Now, if you see here, you need to calculate first the force due to H, okay? And here, if you see these two charges, okay, their resultant will be in this direction. This is the resultant for these two forces. So, when you will see, first you will see what? First, you will see the magnitude of force due to BC, okay? That means the force on the charge B due to the charge placed at C. You know the formula is KQ by R square. So it is KQ by R square will be what? A square here. Because the distance between A and the point B is what? One side of the square. Similarly, if you write force on the charge B due to A. That is also same, kq square by r square. And force on the charge B due to C, it will be equals to what? Kq square is same, but the distance between this charge and this charge is the diagonal, which is root 2a whole square. So here what you will get, kq square by 2a square. Now if you see here, this to magnitude, okay? Magnitude of force on B due to C, it is equals to what? Force on B due to A. That is equals to what? Kq square by A square. And the resultant Fr, you know the formula for resultant is what? F of what? BA square plus F of BC square plus twice of F of BC, F of BA, and cos theta. Here theta will be 90 degree, because if you see here, these two forces are having angle 90 degree, okay, at right angle. So this is 90 degree. If you so cos 90 is 0. So this entire term will be what? 0. And you will have the resultant force Fr is equals to be what? These two are equal. So you can just take F of B A square. And if you add it, you will have a 2 here. So it will give you F of R. It is equals to what? Root 2. I'm taking F. Since I write here F of BA, force on B due to A and force on B due to C. These are equal. So it is considered to be F here. Clear? Now you will write the net force, F net. Okay, when? At the point B. It is the sum of what? The resultant force, Fr, okay, plus the force on B due to the charge space at D. Clear? So it is root 2. What is the magnitude of this force? It's kq square by a square. And here what you are having this value to be? Kq square by 2a square. So it's simple. You can take kq square by a square common. And in the bracket what you will have here? If you see here, it is root 2, right? This is what you are having. And here you are having plus 1 by 2. Right? It is root 2 plus 1 by 2. And further, you can write this k to be 1 by 4 pi epsilon naught q square by a square root 2 plus 1 by root 2. And you already know this k is equals to what? 9 into 10 to the power 9. Or you can write 1 by 4 pi epsilon. So whenever you are given identical charges, you can directly use this particular formula and do it. Or you can just use this. Okay, you can just write root 2f plus force due to this. Just put the magnitude and you can solve it very easily. Now we will solve one question related to this, means you need to calculate the force at any one of the vertices. So now we will see a problem. So here it is said 4 charges of magnitude plus 6 into 10 to the power minus 8 are placed at the 4 vertices of a square of side 3 centimeter. Okay, and you are asked to calculate the net force on each charge. So the value of the charge is same on all the 4 vertices. Side for a square is 3 centimeter. That means we know all the 4 sides of a square is equal. So this is a very simple question. Just we have done the theory part now, and directly also you can do, but here we will do stepwise step. Okay. So this is a square A, B, C, and D. And what is the side given to us? It is 3 centimeter each side. Okay. So all the 3 sides are 3 centimeter. Now the diagonal. First, let us calculate the diagonal. Okay. So the diagonal will be how much? By Pythagoras theorem, you will get it to be, if you see the Pythagoras theorem, you know the longest side will be what? 3 square plus 3 square. That is 9 plus 9. So it's at 18. And there will be a square, right? This is BD square. From here, you will get the diagonal to be root 2, root over 18. So it will give you 3 root 2. Clear? So here you're getting it to be 3 root 2. We will convert it into meter and we will write 3 into 10 to the power minus 2. Okay, just 10 to the power minus 2 will be multiplied. So here if you see, charge space at the vertex A equals to charge space at the vertex B equals to charge space at the vertex C equals to charge space at the vertex D is 6 into 10 to the power minus 8 Coulomb. Okay, here you are having the distance. Okay, side I'm writing, just A I'm writing. Okay, side of square is 3 centimeter, that is 3 into 10 to the power minus 2 meter. Now we will see the force at any one of the charge. So I'm considering the point B. So here if you see, the force is repulsive on the charge placed at the vertex B due to A. So force on the charge B due to A is repulsive. This side also he will have a repulsive force on B due to C, and here on B due to D. Okay, now if you see here, first we will see the magnitude. Okay, the magnitude of the forces. So force on B due to C, it is equals to what it is equals to K. You know the Coulomb's law is K Q square by R square. K is the constant, Q is the product of the magnitude of charges, R is the distance between them. So here if you see here, K, the direct value I'm putting 9 into 10 to the power 9. Okay, and Q square is this. So it is 6 36 square, and 10 to the power minus 8 will give you minus 16 by what you will have R square. The distance between them is how much? 3 centimeter, which is 3 into 10 to the power minus 2 meter with a whole square. Alright. And from here you will get 9 into 10 to the power 9. Okay. Into 36. Into 10 to the power minus 16. This 10 to the power minus 2 will go in the numerator and it will become positive. Okay. It will become positive. And 2 square is 4. And in the denominator you will have 9. 9 and 9 get cancelled, and here you will have 36 into 10 to the power minus 16 plus 13. Okay, and it will give you 36 into 10 to the power minus 3. Okay, minus 3, which can be written as 3.6 into 10 to the power minus 2. And if you see this force, BC will be equals to the force on the charge B due to A. Both are equal. So I'm considering this to be F. And the resultant will be in this direction. Okay, and the resultant you already know, you calculate it to be root 2 F last. You can just see the angle between them is 90 degree, and it is what the resultant, the formula for resultant is what? It is F1 square plus F2 square plus 2 F1 F2 cos theta. Theta is 90, so this term will get cancelled. And these two forces are equal magnitude. So it is F1 plus F1 square, right? So it is root 2F. And the net force, okay? The net force at what? At the vertex B, it is what? It is the resultant of Fr plus the force due to on B due to D. So we need to calculate the force on B due to D. So it will be same. Here you will have 9 into 10 to the power 9, and here you will have a 36 into 10 to the power minus 16. And in the denominator you will have the distance. This is 3 root 2 centimeter. That is 3 square is 9 into 2. This into 10 to the power minus 4. So here if you see 9 and 9 gets cancelled. This is 36. So it will be what? 18. And again here you will have seen minus 16 plus 4, it is again plus 9. So it will be 10 to the power minus 3. And it is 1.8 into 10 to the power minus 2 Newton. So this is the value. This is also Newton. So just put the values here. You will have here it will be 3.6 into 10 to the power minus 2. And here you will have what? Root 2F. The resultant, okay, this is in bracket. Plus here you will have 1.8 into 10 to the power minus 2. So here if you see, if I take common 1.8 into 10 to the power minus 2, what will be here? It is 2 into root 2 plus 1, right? And we know root 2 is equals to 1.414. Okay, so it is 1.8 into 10 to the power minus 2. When you will multiply this root 2 value with 2, you will get 2.83 plus 1. Okay, and this will give you 1.8 into 10 to the power minus 2 into 3.83. And when you will do this entire calculation, when you will multiply 1.8 with 3.83, it will give you 6.89 into 10 to the power minus 2 Newton. This much of force, and this force is along which direction? It is along force along BD. Okay, sorry for the interruption. This is force along BD. Clear? So this is how you can calculate. If the nature is changing, then you will just change the direction of the force and calculate it. That's all in this video. Thank you so much. Have a good day.